Okay, we're going to be looking through the review for the quiz in Algebra 2 Honors that is on Thursday. So this is the review for Wednesday. Whoops, see, that is not what I meant to do. Alright, so let's look at numbers 1 through 4. State if the parabola opens up or down. State the coordinates of the vertex. State the vertex max or min. Give the equation for the axis symmetry, give the domain, the range, and make the graph. So, for the first one, we have y is equal to negative x squared plus 2x plus 4. Alright, so our a, b, and c values, negative 1, b is 2, c is 4. Our axis of symmetry, negative b over 2a, which means negative 2 over 2 times a, so negative 2 over negative 2. So that would be 1. So the axis of symmetry is 1. X equals 1, that's the line. Of course, this is a negative a value, so this opens down. We will find the vertex by, we have the x coordinate, 1. We need to substitute the x coordinate into the equation to get the y coordinate. So you have y is equal to negative 1 squared plus 2 times 1 plus 4. So 1 squared is 1, so that's negative 1 plus 2 plus 4. Negative 1 plus 2 is 1, plus 4 is 5. So the rest of the vertex is 1, 5. And then of course the y-intercept is the c value, so this would be 0, 4. Alright, so this is all the information we need to graph this. Our axis symmetry, vertical line that goes through 1 on the x-axis. The actual vertex is at 1, 5. The y-intercept is at 0, 4, so that's right here. So to reflect that would be on the other side over here, and then we can draw our parabola. The domain of this, of course, is all real numbers, so negative infinity to infinity. The range of this is the lower bound. It has no lower bound, so it's negative infinity to the upper bound, which is 5. So negative infinity to 5. And that should answer everything we need for number 1. Number 2, y equals x plus 2 squared plus 1. Oh, I forgot to do the minimum and maximum. Of course, it was a maximum in the previous problem. This is number 2. Y equals x plus 2 squared plus 1. So this is in vertex form. So in vertex form, we have A, H, and K. A is 1 because there's nothing here. H is negative 2, and K is 1. So our axis of symmetry is x equals h, so x equals negative 2. Our vertex is negative 2, 1. Of course, this opens up because the a value is positive, which means that it will have a minimum. And then the y-intercept, we simply need to substitute 0. find the y-intercept, we simply need to substitute 0 into the equation. So 0 plus 2 squared plus 1. So that would be 2 squared, so that's 4, plus 1, so 5. So the y-intercept is 0, 5. So we have the axis symmetry, the vertex, the y-intercept. That's all we need to graph this. So negative 2. Negative 2, 1 is the vertex. The y-intercept is 0, 5. Right here. So to reflect that, I would get the partner point on the other side here. Connect these to make my, make my parabola. Let me see if I can get this other side to work. Yeah, something like that. The domain of this, of course, is all real numbers, negative infinity to infinity. The range, the minimum is 1, and it has no maximum, so the range is 1 to infinity. That's number 2. Number 3, y is equal to 2x squared plus 8x plus 5. 2x squared plus 8x plus 5. So here we are looking at standard form. So A, B, and C. A is 2, B is 8, C is 5. The axis of symmetry we will find by doing x equals negative b over 2a. So that's negative 8 over 2 times a, so that's 4. So negative 2. So the axis of symmetry, x equals negative 2. Of course, this opens up because of the a value of 2, which means it has a minimum. The vertex, we simply need to substitute the negative 2 into the x. So we have y is equal to 2, negative 2 squared, plus 8 times negative 2, plus 5. So negative 2 squared is 4. That's negative 16, plus 5. So we have 2 times 4, which is 8. So 8 minus 16, which is negative 8, plus 5, negative 3. So the vertex would be negative 2, negative 3. And the y-intercept is, of course, the c value, so 0, 5. Alright, I am going to have to erase this to make room for my graph. So my axis of symmetry is at negative 2. Negative 2, negative 3 is my vertex, which is right here. 0, 5 is my y-intercept, so I would reflect that to get the point on the other side. Connect these to make my, should go through the point. Yeah. And that is what my parabola should look like. My domain, of course, negative infinity to infinity, all real numbers. My range is from negative 3 is my minimum, and it has no maximum. It goes up forever, so it's negative 3 to infinity for my range. And that's number 3. Number 4, y is equal to negative x minus 1 squared minus 2. This one is in vertex form, so we have a, h, and k. A is negative 1 because there's a negative 1 outside here. H is just 1, and k is negative 2. So this opens down, which means it has a maximum. The axis of symmetry is x equals h, so x equals 1. The vertex is just h comma k, so 1 comma negative 2. And the y-intercept, of course, to find the y-intercept in vertex form, we plug in 0. So I have y is equal to negative 0 minus 1 squared minus 2. So negative 1 squared minus 2. Alright, so this is where most mistakes are made. The negative 1 gets squared and then multiplied by negative 1, this negative sign. So negative 1 squared is positive 1, but this negative sign on the outside keeps it a negative. So it's negative 1 minus 2, which is negative 3. So the y-intercept would be 0, negative 3. So I'd need to graph this, 1, negative 2, or sorry, here's my axis of symmetry at 1. 1, negative 2, right here. My y-intercept is 0, negative 3. Reflect this to get the point on the other side. And then draw my parabola. It looks a little something like this. Not perfect, but something similar. My domain is negative infinity to infinity. It's all real numbers. My range has no minimum. It's negative infinity, but the maximum is negative 2. So that's my domain and range. Number 5. State the coordinates of the y-intercept for each. Okay, so this one's going to be fairly straightforward for both of these, so I'm just going to use this space over here on the bottom to do this. So number 5, this one's in standard form, 3x squared plus 2x plus 5. So the y-intercept would be the c value, which in this case is 5, so 0, 5. Number 6, however, this is in vertex form. So to find the y-intercept, we would substitute 0 in for x to find the y-intercept. So that would give me 1 squared minus 4. So 1 squared is 1, minus 4 is negative 3. So the y-intercept for number 6, 0, negative 3. Number 7. If you throw a ball upward, its height in feet above the starting point and t seconds is shown below. So we're going to have x, y ordered pairs, or I mean technically t, h ordered pairs. But the x would be the seconds, the y would be the feet. So we could rewrite this as y is equal to, but I mean it's going to be the same thing, except t is x, h is y. So find how long it takes the ball to reach its highest point. So its highest point is going to be the vertex, since this this opens down. So our A is negative 16, B is 32, C is 0. So the how long, that's going to be the x coordinate of the vertex. So we're going to do x is equal to negative b over 2a. So it's negative 32 over 2a, so negative 32. So it's going to take 1 second for it to reach its highest point. It's going to take 1 second to reach the vertex. Now if I want to find the actual maximum height, I have to substitute the 1 second into the equation. So it's going to be negative 16 1 squared plus 32 times 1. So 1 squared is just 1, so this becomes negative 16 plus 32, which is just 16. So the maximum height would be 16 feet, and that would occur after 1 second. And that would be the vertex. That would be, it looks like this. At the top here is the maximum height. That's the vertex. 1 comma 16. 1 second, 16 feet. So that was number 7 and number 8. Number 9 and number 10. Okay, so number 9, we are solving by graphing. So number 9, we have y is equal to x squared minus 4x plus 3. Y is equal to x squared minus 4x plus 3. Alright, so we need to make a graph of this, and then we need to see where the we're looking for the solution. So the solutions are the x-intercepts. So we're going to draw the graph of this, and then we're going to figure out where exactly does it cross the x-axis. A is 1, B is negative 4, C is 3. Our axis of symmetry is x equals negative b over 2a. So 4 over 2, which is just 2, so the axis of symmetry is 2. The vertex, 2 comma something, I need to substitute 2 into the equation to figure out what that something is. So 2 squared minus 4 times 2 plus 3. So 4 minus 8 plus 3. 4 minus 8 is negative 1, or sorry, negative 4, plus 3 is negative 1. So the y-coordinate is negative 1. So the vertex is 2, negative 1. And of course, the y-intercept is the c value, 0, comma 3. I can use all of this to graph this and see where it crosses the x-axis. So axis symmetry at 2. 2, negative 1 is, let me do that in a different color. 2, negative 1 is right here. 0, 3 is our vertex, is y-intercept, and we can reflect it to get our other y-intercept. So we can see where these cross the y-axis or the x-axis, or we can get a pretty good estimate by looking at the graph where these cross the x-axis. We're going to have two solutions here. The first one is going to be right here. The second one will be right here. So the first solution, x is equal to 1. The second solution, x is equal to 3. Those would be the two x-intercepts. Those would be our two solutions. This has two solutions here, or 2 roots, 2 zeros, lots of different names for what these are called. But when you're looking at the graph, you're looking for the x-intercepts. Number 10, same type of problem. We have y is equal to x plus 2 squared minus 1. We are looking for the solutions, which means that we're going to need our graph. So we're looking at our A, H, and K. A is 1, H is -2, K is -1, which means that our axis symmetry, x equals -2, our vertex, -2, -1, our y-intercept, since this is in vertex form, all this information is coming for me. The y-intercept, however, I do need to substitute 0 into the x-coordinate. So 0 plus 2 squared minus 1. So that's 2 squared minus 1, 4 minus 1, which is 3. So the y-intercept is going to be 0, 3. So I'm going to use all of this to graph, and then hopefully I will be able to see where the graph crosses the x-axis, which will be my solutions. So I got -2 is the axis of symmetry. My vertex is on that. It is -2, -1. My y-intercept 0, 3. And then its partner over here on the other side. I should be able to see where these cross the x-axis, even if I don't draw my graph perfect. I can see I've got two intercepts here. These are my solutions. I have two solutions, x equals -3 and x equals -1. Those would be my two solutions to the equation because they are my x-intercepts. Alright, and that just about does it for the review. Thanks for joining. I hope you learned something.